This is the last formal lesson for this unit, and our topic is problems with triangles. Yes, and triangles have problems. However, I'm talking about, in most cases, word problems that we have to deal with. Now, our goal today is I know when to use sine law and cosine law if I'm not told which to use in the question. And this is often a concern when we're dealing with word questions because we have our primary trig ratio, SOHCAHTOA, and we have our sine law and cosine law. But if they don't tell you which one to use, we need to be able to figure that out ourselves. So the first activity that we're going to do together is on the left-hand side, I have 4 triangles. In the middle, I have some different formulas, sine law, cosine law, and the different forms. And then to the right-hand side, I have y. I'm choosing one over the other. Okay, so let's first of all, I'm just going to take an arrow and I'm going to make it, we'll do colored, we'll do red, and we're going to make it dotted. Okay, so first of all, let's see. If I want to find this side A, what law could I use? Well, it looks like I have one side, two sides, and an angle in between. So one side, two side, angle in between. So it's like a Pac-Man situation. So let's look. Well, sine law, I need to know an angle and the side directly across. So it can't be that one. Cosine law, oh, this is finding an angle. That's not going to work. Oh, here it is way down here. Okay, so I need to use the cosine law to find a side length. Okay, so I'm finding this side and I know the angle. Okay, so that means I need two sides and the angle in between. Two sides and the angle in between. So let's find the two sides and the angle in between. So that's why it's cosine law. Okay, it might get kind of colorful by the time I'm finished here. So now let's look at the next triangle. The next triangle, I have all 3 sides. Okay, well, there need all 3 sides, but what law do I use for that? Well, again, that was cosine law, but in this form, and need all 3 sides. Now let's look at the next ones, and it's kind of easy, right? Because you're thinking, hey, what's left is a sine law. Yes, but why is it the sine law? And again, let's change colors. We'll do purple now. Okay, so this time I have, I have 2 angles, so I really have 3. I do know the angle and side directly across, so it is sine law, and I could use either form of it, and so it might be easier to use the top one. So I need an angle across from side and another side. I need an angle across from the side and another side. Well, I don't have another side here, but it still would work. And finally, the last one also has to be sine law. And as I said, I don't really care which form of it you use. And what color should we use? Maybe this color. Okay, and I need an angle across from a side and another angle. Okay, and I'm finding another angle. Okay, so I know this directly across. That's why I can use the sine law. Okay, so that's kind of a little bit of a review of when you can use it. But what we're going to do is we're going to actually do some examples and work a little more closely with our sine and cosine law. So our first example. All right, so it says, to get around an obstacle, a local utility must lay 2 sections of underground cable that are 37.1 meters and 40.0 meters long. The 2 sections meet at an angle of 145 degrees. How much extra cable is needed to go around the obstacle as opposed to a straight line distance between them? Okay, so let's take a look at this. So I'm running a cable according to this, And that cable, I guess we're using green. So I have one section that is 371 meters. I have another section which is 440 meters, and I have the angle where the two sections meet. Okay, so, and we have the obstacle is in this location here. So we have this obstacle and we're going around it. Okay, so here's my obstacle. My obstacle is a circle, and I'm going around it. So finishing up what I have here, I'm going to have my measurements, and as I said, the one was 371. The other one was 440. And we're told this angle is 145. And we're asked to find this section here that joins the two of them together. So this is the part that I want to know. Okay, so that's the D or the H or whatever you want to call. So that is the length I want to find. So I could actually even put it as an X. So what law am I going to use? Well, I have two sides and an angle that is holding them together. So it's the Pac-Man situation. So that's the cosine law. So the first thing I'm going to do is I'm going to write down that, yes, I am going to use the cosine law. And because I am finding a side length, I want the form of the cosine law that actually finds the side length. So that's c squared, and remember I have to have the cos of c. I have to know angle c, which I wasn't doing. And so then I have my other sides a squared plus b squared minus 2 times a times b cos of c. Now I'm going to substitute my information in. So I'm finding x, so that's x squared equals my 440.0 my 371 minus 2 times 440 times 371 times, and remember it is times, the cos of 145 degrees. So what we're going to do is we are going to multiply these, square these, add them, and multiply this all together. Now, if you have a really good scientific calculator, you could actually type all of that in. And when you do that, and you can try this on your calculator, you should get 59867. And I'm going to keep quite a few decimals because I still have to take the square root. 759. Okay, so that is x. So that means x squared, so I need to take the square root of that, which would be approximately 774. Okay, so what we have found then is this straight across here. So now, is that exactly what they asked me to find? Well, it said how much extra cable is needed to go around the obstacle as opposed to a straight line distance between them. So if you look, if I went straight across, it's 774. But is that really what they're after? Well, not quite, because what they suggested is if I went around, and what they mean by around is if I start here, go all the way around and then across. So it's, get back your pen. So really what it would have been if I went around, it would have to be 440 plus the 371, which would equal 811. So if I had to get around this obstacle and I had to put in 2 cables, it would take 811 meters compared to if I needed to get around this obstacle and actually just starting my cable in each corner here and putting a cable straight across, and my pen doesn't want to work for me, straight across, that would only take 774 meters. So the extra, because that's what the question is asking, is how much extra cable would be 811 minus our 774, which would be 37 meters. So it would take 37 meters extra. It would be 37 meters extra. Now you're saying, oh, well, that's not too bad, if I went around and dug it in like that. Well, depending on what kind of cable I'm putting in here, the cable could be quite expensive. So 37 meters extra cable could actually turn into thousands and thousands of dollars. All right, so let's try getting another example done here. So